All right, so to get us started working and getting familiar with our studio, I have prepared this classwork assignment. So remember, CW stands for classwork in our Canvas page, and I have created a template notebook that we're going to be completing different pieces in this practice set of problems to get familiar with some operations in R. Again, we're going to open this RMD file that stands for an R Markdown file, and we're going to open that in RStudio or in your RStudio.cloud instance. I have opened right now RStudio, and also I have logged into my RStudio.cloud account just to show you how the two different processes would work. Okay, so first things first, if you go to Canvas to the CW Practicing Operations in R page, just download that file that I have included there by clicking on it. When you download the file, you can simply look at that, locate that file in your downloads folder. In my case, I can just click on it, and you would see that it will open up immediately in your RStudio session. You can see also that this file is an HTML notebook. Now, the next thing I want to try to do is upload this file into my RStudio.cloud project. So this is how my RStudio.cloud project looks like. You can see that I have created a project. That project number is up there, and I name it Fall 2020. In order to upload this file into your RStudio project, you're going to click on the bottom right, the Upload button. If you click there, it's going to ask you to browse the file that you want to it's going to ask you to choose the file that you want to upload. So you want to do that. Locate your file. In my case, is that one, and then click OK. Once that is done, this file has been uploaded to the cloud, and now you can simply click on it, and it will be ready to go. All right, so I'm back in RStudio now that we have been able to open the RMD file, the R Markdown file that I generally use as templates throughout our course. We're going to fill in the missing pieces of each of these chunks of code in R and get familiar with some of the operations in R. I have included a lot of text already, so anything that is not part of a chunk of code, so anything that is with the white background is literal text that you can use to add your own notes if you want, and this is a good way that you can take notes throughout the course. The first thing that I'm going to show you is how to define two vectors. I want to define a vector called x and a vector called y, and we're going to be using a function called the C function. That stands for combining or concatenating. It's a very powerful function in R, and we're going to use it all the time. So here's how we do it. I'm going to call this vector x, and we're going to use the assignment operator, that is the less than hyphen operator, the left arrow operator. And again, as I said, we want to make use of the C parentheses function. So I type C parentheses, and I'm going to fill in the entries of my vector. My entries for this particular example will be -3, -2, let's put a -1, let's put a 0, a 1, a 2, and a 3. So this is a vector. Now I also want to define y, but just to show you the type of operations that you can do in R, I'm going to define y depending on x. So y would simply be x raised to the power of 2. What this really means is that y will be a vector of the same length of x, but every entry of y will be nothing but the square of every entry of x. So to run this chunk of code, again, remember that you can locate the play button on the top right of your chunk of code and run it. Once you do that, you'll see that now your environment has two objects, that is x and y. They have the same length, and one is the square of the other. Now, a common function that we use generally to try to get a sense of what type of data we're using and working with is to get the arithmetic mean of a particular set of observations. So in this case, to get the mean of x, I could just type mean x. Mean is a function in R that will compute the average, and to compute the mean of y, I'll do the same. I'll do mean of y. Again, we run this chunk of code, and we'll see that the means are 0 and 4 respectively. All right. We also may be interested in calculating the standard deviation of both of these vectors. So what we can do is just use the SD function, the argument is x, and again, the SD function, the argument will be y, and I'm going to run that chunk of code. You'll notice that I have a quick shortcut to run my chunk of code instead of having to go all the way to the top right of the chunk and clicking the play button. In my case, I did Command-Shift-Enter. On a Windows machine, I think you can do Control-Alt-Enter. Now, I also want to check the correlation between x and y, and there is a function for that in R, and it's the COR function. So that function expects two vectors, in this case x and y, and it will compute the Pearson correlation. Now, remember that the Pearson correlation in this case measures the strength and the direction of the linear relationship between the two variables, if there's any. So I like this example because it shows that the correlation between x and y is 0, so meaning that linear relationship is 0. But really, we know that we built y depending on x by taking every entry of x and taking the square of that. All right, so let's talk about data sets. It turns out that R actually comes already with a lot of built-in data sets that sometimes we use so that we don't have to load anything from an external source, and that we can test different algorithms, and we can test different functions and see how they would perform with different methodologies. Now, R has a variety of built-in data sets. I can give you an entire list of them, and one popular one is the empty cars data set. This is data extracted from the 1974 Motor Trend US magazine, and it has data on 32 different cars with 10 different attributes. So remember, when we talk about features or attributes, those are really the columns of our data frame. And when I talk about a data frame, we're talking about something that is a rectangular array of numbers or data, actually. In this case, if you just type empty cars, meaning you want to print the object empty cars, you're going to get a printout on your R notebook that will give you the information for each of the observations. You can see that we have 32 rows, that we have 11 columns, that means 11 attributes, and we can already see that we have some attributes that are understood as continued variables, while others, even though they're understood as continued variables like AM, really are binary. They're 1 and 0s. So, when we are exploring data, these are little things to keep in mind and to be aware of. Similarly, the cylinders variable is nothing but a categorical variable in this case, and it's got fixed and discrete values. If you want to learn more about the empty cars dataset, remember that R Studio comes with documentation of every single object and every single function that you're using. So if you click on the Help tab and you type on the search bar empty cars, and R Studio will try to autocomplete for you, you'll see the information that I just mentioned. You can also see specific information about the definition and how different attributes were measured. So how is the weight measured in this case? How is the miles per gallon measured in this case, US gallons? And also some references that sometimes mention where these data sets have been used, or what type of study gave inspiration to this type of data set. Sometimes also you have some examples to try to play around with what you can do with the data set. All right, so empty cars, we don't even have to load that data set into our R Studio session. It's already loaded when you open your R Studio. Now, typically, one thing that you want to get familiar with is exploring your data by looking or taking a quick snapshot of maybe the first 6 observations. And you can accomplish this by using a function called head. So if you use head parentheses and type empty cars and run that chunk of code, what you're going to observe is the first 6 observations. And obviously a natural question is, can I print now the last 6 observations to see if there's any variance or if I notice anything in particular? And the function for that is called tail. So TAIL parentheses empty cars, which is our data frame in this case. So this will print out the last 6 rows. Natural questions that we usually get is, can we print more rows? And the answer is yes. And all of those things are embedded in the documentation for the head and the tail function. To finish up this notebook, this practice notebook that is our first exposure to some operations in R, I wanted to show you and talk to you about a function called summary. Summary is a function that is very powerful, and it will return summary statistics for every variable in a given data frame. So since we have so many different columns, in this case 11 different attributes that we want to get some summary statistics of, it really just takes one line of code to get some information about the distribution of those variables. So if I use the summary function by typing summary and passing as an input or as an argument the empty cars data frame, and I'll go ahead and run this chunk of code, what you'll observe is that you get these summary statistics for each of the variables involved in this data frame. It's a really powerful function. It gives you an idea of how the variance and the mean and the median of your different attributes look like. And I will always suggest to just do a quick check so that you get familiar with this. As a final check, let's save our notebook, and remember that we can preview a notebook. And to do that, you can click right next to the magnifier icon. There is a preview button that if you click on it, it's going to generate this HTML file. Again, this is really good because HTML files are really good for portability. And generally, I'm going to be asking you to upload an HTML file as your submission for a given assignment. That way I can see what you type, I can see what output was generated from your code, and I can see the comments, such as this one, of what you are trying to explain.